to GalaxySpaceTalk. My name is Nanekia JC and I'm the host. With me here is my guest, Solomon Agbeli. He is a current student at the Presbyterian Boys Senior High School, Legon, and Charles Zazi, the mission engineer at Galaxy Aerospace Ghana. Thank you for joining us for today's podcast.
Thank you.
Today, we are treating an interesting topic, and it's all about why is the sky blue? I believe you've asked yourself that question before. Why the sky is blue during the day and dark at night? We are here to tell you more and to educate you and let you know why it's so. Charles,
Yeah.
I'm sure people are wondering, and I myself am wondering, why does the sky appear blue during the day?
Okay. Thank you, Kia. I think when I was a kid, I asked that question, and I was told that I should mind my own business because we came to meet it, and that is how it is. But we have come to realize there's a reason behind the sky being blue, and we want to reiterate that the sun is not sticking uh, on the blue. People think the sun is sticking on the blue, so the sun is running over the blue in the sky. But this is not so. What we are actually seeing is our atmosphere. That is what we are seeing. So the sun is behind our atmosphere. That is giving us white light. Remember, white light is divided into 7 light spectrums, which we all know, which is the Roig wave. The red, orange, yellow, green, blue, indigo, and violet. Yes. So that is the white light that is coming from the sun into the atmosphere. The atmosphere has a lot of particles. I mean, we have nitrogen, which is about 78%. We have about 21% oxygen, which we all learned in school. Now, we'll probably be using the word wavelength. And I believe as time goes on, we'll understand the word more. So with each light spectrum, we have a specific wavelength. And as per what we know, the blue spectrum has a shorter wavelength. And once it hits certain particles in the atmosphere, which have about just the same wavelength, it will scatter it, basically. So that is why the sky is blue. The sun is white, it is giving you white light, but particles in the atmosphere have scattered it based on the wavelength that they carry. So this is basically why we see the sky as blue, and not that the sun is as in front of that sky. It is behind the sky, but you are seeing the blue color disperse as a result of its wavelength and as a result of the nitrogen and oxygen particles and other particles scattered in the
Okay,
atmosphere.
all right. So talking about wavelength, he was talking about wavelength. So how does wavelength affect light in scattering in the sky?
Okay, so the shorter the wavelength, the more easily it scatters, or the less particles it takes to scatter that wavelength. So, for example, it will take less particles to scatter blue than to scatter like maybe colors like red or orange. So, because the sun is giving us white light, which we know from primary and JHS is made up of 7 colors, the blue scatters more easily, or it disperses more easily. So, we are able to see the blue more than the other colors. That's why the wavelength of the color has a direct effect to how much it is scattered by the particles in the atmosphere.
Okay. Okay. So amongst the colors, blue actually scatters easily. But I've heard people also say that violet also scatters easily. What's the difference between that? What do you have to say concerning that?
Well, when you look at the color spectrum, you realize that violet has the shortest wavelength, right? And the next shortest wavelength is blue, okay? But the sky actually sometimes looks bluish into that violet color. So it's in the daytime, it's sometimes it's like that. But blue, and especially the nitrogen particles in the atmosphere, they have just about the same wavelength as the blue light.
Okay, but you just said that violet
Has
actually
has
has
a
shorter.
shorter,
So
yes,
why doesn't it appear violet?
yes. That's why I'm saying that it's not just about the shorter the wavelength, it's about the particles as well, right? So if I am hitting a particle, right, which has just about my wavelength, it could be red, right? It could be red. And if red particles were at the top, that would scatter first. Nitrogen is at the top. It's most dominant in the atmosphere, 78%. And it's that particular one that usually scatters that spectrum, that blue light spectrum. Because it is nitrogen is predominant in the atmosphere. Oxygen is just 21%. It also scatters it. But I think violet is not scattered by nitrogen. So you don't see the violets more,
More
yes,
like
but you
the blue.
see like the blue. Exactly.
Okay. So I'd like to find out why does the sky change color at sunrise and sunset? What causes that?
All right, so as we discussed earlier, the atmosphere is what scatters the white light we get from the sun, changing the color of the sky. Now we have to first notice that the sun doesn't change color. It's still emitting lights, white lights during sunrise or sunset, or when it's at the zenith, the peak of the sky. But what happens is that more atmosphere receives that light. If you take into consideration the fact that during sunrise or sunset, the sun is almost horizontal, more atmosphere scatters the light that the sun gives out, meaning that particles, the wavelengths like red and orange are allowed to be scattered. So we are also able to observe them during those periods of time. However, as the sun moves, less and less of the atmosphere, meaning less particles, are allowed to scatter the light. And that's why eventually from sunrise you get this bluish hue that we are all used to.
Okay.
So,
So okay.
so let me top it up for you. Okay. As rightly you said, the sun is more further away as it goes into sunset. So there's more atmosphere. So it scatters most of the blue light out. You understand? Because this time the atmosphere is much longer, as you said. So this time, all the blue light has been taken away by the atmosphere. So when it's directly on top of you, it is shorter, as you said. But when it's far away from you, it takes up all the blue light. Right. So then it starts giving off different colors, yellow,
Okay.
red, and all.
So
Because now
if
you
I'm
can
getting you, that means there is a kind of scattering that occurs
yes.
that makes it give different shades at
It's not a
different points.
kind of scattering, but the distance in your atmospheric, the atmosphere.
Okay.
When it's right on top of you, the atmosphere is shorter. But when it goes to this section, the atmosphere is longer. So there are more particles that are taking up this blue light and scattering. So it's getting it means that the blue light in the sun is getting finished. It's getting used up. So what you are seeing in the sun is yellowish, reddish, something like that.
So the dark that we see at night in the sky. So is it also from this seven light colors we've been talking about?
Yeah, so I think we spoke about this some time ago that someone asked that why doesn't the moonlight also
Produces a
produce the
different,
same color or
yes,
to
different
give you the
color.
blue
Yeah.
thing, right? And it came to this conclusion that the sun and the moon are of different paths and are of different distances from the earth. You understand? So when white light is reflected from the moon, remember it is the sun's rays that reflect from the moon. Now, when the sun's rays hits the moon, remember the moon also has its color. So it will alter the white light just a bit. And also, the moon is quite close to us. So it doesn't have enough particles to push through so that we can see it. So the moon is just able to reflect that light at that moment. And because of rotation of the earth, now you have moved away from the sun. So you are dark. So the darkness is as a result of Earth's rotation around, on its center of axis.
Okay.
So once you are rotated off, it's now dark. You are not receiving sunlight, but you are either receiving the sunlight from the moon's reflection, which is closer to Earth.
All right. Okay. Why does different locations have different shades of blue in the sky? Because I've realized that thing, and even from our background, we can see that your location might have a different shade of blue than a different location, comparing the sea to Earth or to something.
Okay, so it all has to do with atmosphere composition. Remember, it is the particles in the atmosphere that are scattering the white light to give us the bluish hue. So the amount or the variations in the amount of atmosphere also cause a variation in the amount of scattering. Meaning, as you said earlier, the more particles there are, the more they absorb or scatter the blue light. So if there are more particles in this particular area, maybe like there's pollution in the area or there are a lot of aerosols being used in that area, the particles might cause a change in the blue compared to a location where maybe the atmosphere is relatively pure. So because of these particles or the changes in the amount of these particles in the atmosphere, we get different variations of blue because there are also different variations of the scattering of white light.
Okay. Talking about pollution, what's the impact of ozone layer, or what's the role of ozone layer in the whole sky?
Okay, we talk about ozone layer when we want to talk about radiation from the sun. Okay, so that is why when people go to space and then they come out of their spacecraft or when they're on the moon, they have to wear a lot of clothing to prevent radiation from affecting their stay in space. Right. So the ozone layer is supposed to prevent the extra radiation from the sun, lower the and the atmosphere as well, lower the heat from the sun a bit. You know, Mars has a lighter atmosphere, so radiation is quite high there. So that is the job of the ozone layer, to avoid the radiation from the sun directly.
Does the presence of clouds, affect the color in the sky?
Yes, it does. Okay, so clouds are basically water molecules that have been condensed together. So they can sometimes diffuse the blue light. So you can realize that sometimes maybe the sky will appear gray or the blue is not as vivid as it's supposed to be. That's because of the presence of clouds. They are diffusing or they are diffusing the blue light that has already been scattered by the particles in the atmosphere, changing the color.
Okay.
So the more clouds there are, the whiter the
The
sky
sky will be,
appears.
and the less cloud,
The less
the
clouds, the
grayer.
clearer. That's why on a clear day you can see that the sky is blue,
Okay.
like perfectly blue.
Okay.
But on a cloudy day, you have variations of white and green in the
Gray.
sky.
Okay. Okay. But are there any specific type of scattering? We spoke about scattering. Are there any specific type of scattering that occurs in the sky, making it gives us the shade or the color that it provides?
Just around 1870 to 1890, there was one gentleman, John Stratt Williams. He was Baron Rayleigh. That was conferred to him, the third Baron Rayleigh. And he was the one that was able to bring out an experiment to indicate this sort of scattering. So the scattering of light that we see now was proposed by Rayleigh, and we call it the Rayleigh scattering.
Okay.
Okay, so what we see is the Rayleigh scattering. Yes, as I say, we have what was it, the Maya scattering and other ones as well. But currently, what we know and what we are learning is Rayleigh scattering. That explains why the sky is blue.
Okay.
That's basically it.
Okay. What's the role of scattering in making the sky blue?
So as you said earlier, the scattering of the light is what allows us to see blue.
Yes.
Because light travels in a straight line, frankly. If the light wasn't scattered, we wouldn't be able to observe it. Or we wouldn't be able to see the different colors or hues that are present in the white light. We might detect the pure white light. So it's the scattering of the light by the particles in the atmosphere that allows us to detect the color that is hidden inside them.
Okay.
So it is very important for the scattering to be there. Otherwise, what we might detect might be the pure white light coming from the sun.
Okay. So is that why sometimes the sky appears pink or purple depending on
The atmosphere.
atmosphere?
Yes, everything more or less depends on the particles in the atmosphere, and how they scatter the white light. As you said, there's a spectrum, 7 colors. So depending on how dense an atmosphere is, as he said, or how light or clean the atmosphere is, it is what will reflect how the sky will look like. Basically, we all know that the main color we would always mostly see is blue. Yeah, because of the shorter wavelength and the fact that it's 78% of nitrogen is there and it works with it. So you're able to see more.
Okay. So it's a nitrogen percentage that is there, and then the fact that blue is
Has a
shorter
shorter
wave
wavelength.
as compared to the others.
Other ones, yes.
Yes. But then we know that violet has a more shorter wavelength
than blue.
blue.
Yes.
But we normally see blue,
Blue
as compared to violet.
Violet, yes.
Okay. And also, you made mention that clouds also affect or have impact on how the sky appears. So a more clearer sky appearing blue shows that there are no clouds or less clouds. And then if it appears gray or white, that means there is more clouds. Okay. So my guests, please, do you have any last words for us, Mr. President?
It's a pleasure to be here. And the fact that we have come to know that the sun is not sticking in the blue, but is actually behind the blue and it is showing us the blue. And it's glad that we have learned it today. So this answers the question, why the sky is blue. And the other question, why the sea is blue, is because of the reflection from the sky.
Okay.
Okay.
All right. So,
So this topic explains the variations in the color of the atmosphere. It explains why we see red at sunset and blue at noontime. So it's very interesting, especially considering the really scattering by Byron really. So yeah, I think it's good for children because, as I said earlier, when we were cheated, we asked, we were told to mind our own business. But it's interesting and entertaining to know that, okay, so it's because of particles that the sky appears blue.
Okay. I'm also fascinated by the fact that we have different shades of colors in space, just like we have on Earth. The Roy beef, as we all know, it's not just on Earth, it's in space, and the atmosphere has a role to play in helping us get the blue we see in the sky. Hope you've also learned something at home. All right. So thank you for staying tuned and for joining us. Thank you, Mr. Solomon and Mr. Charles. My name is Nanekia JC, and this is Galaxy Space Talk. Till we meet again, don't forget to like and subscribe and follow us on all our social media channels.